Alright guys, hi if you're watching live and hi if you're watching on the replay. Either way, you are awesome. Thank you for tuning in and trying to understand triangle proofs better. So, this is a major topic that we get questions about every year, and it's definitely something that we'll be reviewing more in class. But triangle proofs are really the foundation for any other proof that we do, whether it's a quad proof, whether it's a circle proof, whatever other kind of proof. Really, at the end of the day, 99% of them boil back down to a triangle proof. So if you really understand these at their core, you're going to understand everything else a lot better. Again, if you're not already in my Remind, go ahead and log into that Remind code down there. You can interact with me live on this. I will also send you a daily Regents review tip of the day, and you can interact with me on any of the live streams because I'll send the code out through that. So at any point tonight, if you have a question, shoot it over to me on Remind or use the chat. You just need to be logged into your YouTube account to do that. But either way, I'll get your message, and I try to make this as interactive as possible. So we're going to go through some basics with triangle proofs. We've already talked a little bit about the 5 reasons, or 5 theorems, and then we're going to go through actually doing a bunch of proofs. I also, in the down bar below this video, will put a ton of practice proof videos where I go through kind of my thought process behind each one and really break down each proof step by step. So if you feel like you need more help with triangle proofs, then that would be another great place to start. So, we're going to start with this, and that's the use of reflexive property. It's something that, again, seems like kind of obvious, saying something equals itself, but I want to make sure we're clear on that before we jump any further into triangle proofs, because reflexive property is something that's going to be important for us. So, reflexive property we're going to use when you have one part, a side or an angle, that is part of 2 triangles at one time. So, for example, if I look at this one right here, I see that I've got the big triangle, right? But then I've got the small triangle, ABM and ACM, and I see that this side is a part of both of those triangles. So this would be a time when I'm trying to prove those 2 triangles congruent, where I might want to say that, AM is congruent to itself, because that might be, in these 2 triangles, a piece of information that I need. Okay? Similarly, in these triangles, I see that little one on the top and then the big one down below. And really what I see is that both of those share angle A. That's an overlap, right? You've got this smaller triangle that has angle A, and then you've got the bigger triangle that also has angle A. So this would be another case where it might be helpful to me to say that angle A is congruent to angle A, because that's overlapping, and so it's shared by both triangles. The time where I don't want you to say this, and I know for a lot of us this is obvious, but I'm just going to make sure, is let's say that we have a situation like this, where maybe we have 2 angles at A right here. Those are not both the same angle, right? Those are not both angle A. So these are different angles. They are not exactly overlapping. One is here, the other is there. Those are congruent because they are vertical angles, but those are not congruent because of reflexive property, because they are not the same exact angle lying on top of each other. If I was going to name this angle A, I would need to use other letters. So maybe this is BAC, right? And then this one would be like DAE, where we would need to use 3 letters to name that. So again, very basic, but let's make sure that we understand that. Common reasons in triangle proofs, these are really the ones you're going to see that we use the most often. Other ones often you can phrase in your own words if you need to, as long as you're sure that you're thorough. But these are the ones that for sure you're going to use all the time. Vertical angles are congruent angles. Midpoint implies 2 congruent segments. A segment bisector implies that you have a midpoint. An angle bisector implies that you have congruent angles. Perpendicular implies that you have right angles. Right angles imply that they're congruent to each other. And parallel lines cut by a transversal implies some angle pair is something. Often its alternate interior angles are congruent. I would warn you with these to make sure that you're giving these as complete statements, right? So something implies something. In my class, we talk a lot at the beginning of the year about toast, right? When I say, why were you late to school? If you just scream the word toast at me, I have no clue what you're talking about. But if I say, why were you late to school, and you explain that you were making toast, and the toast caught on fire, and you had to put it out, and then this caught on fire, and then you had to put that out, and it was this whole chain reaction, I'm going to understand you. So you should be giving me cause and effect, right? If, then statements, not just random splurting words, okay? So make sure that you're saying that. So I'm going to talk you through one where I kind of say what I'm thinking as I go through this, and then we're going to go through a bunch of examples with this. At any time, I want you to send questions. Again, these are not going to start easy and move to be a little bit harder. If you see one that's easy and you want to cut out and come back, that's fine. Or you want to just watch this on the replay, that's fine too. I'm going to disappear for 30 seconds because my charger came unplugged. So take a second while I do that and look at this example. Again, a blank copy of these is on my teacher site. So if you would like to see a blank copy of these notes, go ahead and grab that. Okay, we're back in business. All right, so this gives me triangle ABC with AC congruent to BC and CD bisecting angle ACB. And I want to show that triangle ACD is congruent to triangle BCD. And so here's what I'm going to think through. And I've kind of written out my steps here so you guys can see it. Number one, what can I mark from the given? What else do I then know based on that? So I'm going to start with my given. I know that AC is congruent to BC. So AC is congruent to BC. When I've used it, I'm going to check it off. I've used that piece of the given. Then I know that CD bisects ACB. That's not something I can mark, but bisect means cut in half. So it's telling me that ACB is getting cut in half. Now, getting cut in half means getting cut into two congruent parts. So congruent part number one would be over here. Congruent part number two would be over here. And I'm going to check that off because I've marked it, but notice that's not a congruent statement. So that's something that's going to come back to me in a little bit. I need to make sure I'm giving congruent statements. So then I'm going to say, well, what's my plan and which theorem will I use? So I've marked everything for my given. What else do I see? I don't see any vertical angles. Those would look like an X. I do see an overlap here. These are my two triangles. One is this one here. One is that one there. And I see that there's an overlap, right? They overlap on side CD. That's shared between the two triangles. So I could say that that is congruent to itself. And now I see a plan forming, right? If I go around in order, making sure that I'm not skipping a bunch of steps in between. But let's say I start at B. I have side, and then this angle, and then that side. Same thing on the other triangle. I have side, this angle, and then that side. So my plan here is to use SAS. And I always write my plan over here so that I know where I'm starting, okay? Now this is important, step 3. What can I check off in my plan from my given? Only check off congruent statements. If you've not made a congruent statement, you have not proved it yet. So from my given, I have one congruent statement. I have AC is congruent to BC. That is a side. So I'm going to check off one pair of sides. That's what I know. Now, the angles were not given to me as a congruent statement. I got that from the bisecting. So I know that I need to make that statement via the bisecting. And the other side I got from the reflexive property. So those are the other parts of my plan. So I am going to start writing my proof here. So statement and reason. And number 1 is always your given. And make sure on the Regents that you're copying that down. I know sometimes in our notes or on our homework we get a little lazy. We decide not to copy it. But on the Regents you want to make sure you're doing that because we want to give you all the points that we can. And if we don't see that your given is copied, we can't give you that point. So make sure that you're copying this whole thing down and writing it in there. Now, the next thing I'm going to do, I already know that I have this one, so that's shown. So let's look at the angles now. Let's look at the angles. So you can either name these angle ACD and angle BCD, or the easier way to do it is say angle 1 and angle 2. You might ask, does my teacher like that? Well, your teacher has to grade about 500 of these proofs. Your teacher loves that. Less work for them, right? So angle 1 must be congruent to angle 2. How did I know that? Let's refer back to our given. They told us here that this was bisected. Angle ACB was bisected. So what I have is an angle bisector, and that gives me 2 congruent angles. So now that's my second congruent statement. So I'm going to check that off. Okay. Now, third, I wanted another side. And that side I had originally marked with CD. And I said that was congruent to itself because it was shared between both triangles. So that is by reflexive property. If you want to get really fancy, you could say reflexive property of congruence, reflexive property. And so now that's my third congruent statement. So I've made the other congruent statements. Once I've checked off my whole plan, now I can say the triangles are congruent. So step 4 here is to say the triangles are congruent. Notice I didn't say once I check off all my things, that means I'm done, because I'm not always just proving the triangle is congruent. But, so what I can say now here is that triangle ACD is congruent to triangle BCD, and my reason is side, angle, side, because that was my plan, right? Now I've done that. So now I'm going to ask myself step 6, which is, do I need to show anything else? Look at what you were trying to prove. Was it just that the triangles were congruent, or do you need to go a step beyond that? In this particular example, I see it was just that the triangles were congruent, so I know I'm done and I can stop. So again, as we're going, send questions, okay? You guys can send questions at any time. All right, let's look at this next one. So, next one says, I have an isosceles triangle that signals something to me already with CA congruent to CB. So, isosceles triangle, I think 2 equal sides. I also am thinking something else in my mind, and I hope you are too. Whenever I see 2 equal sides in an isosceles triangle, I also think something else. Now, I also know that D is the midpoint of AB. So, D is the midpoint of AB. That gives me that this must be congruent because I see that the midpoint would divide it into 2 congruent segments. So far I have 2 sides. Now there's 2 different ways you could prove this one. You could go again with reflexive property, right? We see that CD is overlapping between these 2 triangles. That would totally work. But let's go for the less obvious choice here. What I would say is when I see isosceles triangle with 2 equal sides, I also think, hey, that means I have 2 equal angles. So I know that CA is congruent to CB. That was given to me. Because this is an isosceles triangle, 2 equal sides, 2 equal angles, I could also say here that angle A has to be congruent to angle B. And that's because the base angles in an isosceles triangle are congruent. Now again, you could do this with reflexive property and be done. We're going for a little different approach here. So I'm going to do side, angle, side on this approach. You could also do side, side, side if you did reflexive property. So let's do this proof. Let's statement reason this. Again, make sure number 1 is copying your given exactly, rewriting it out. I am going to save the time only because this is a live stream, but you should be copying that out completely. So number 2, let's see what we've got. From my given, how many congruent statements do I have? I have this 1, so I'm going to check that off. So now maybe let's look at our angles. So I can say here that angle A is congruent to angle B, and the reason I know that is this. I can say in an isosceles triangle, I know that the base angles are congruent. Or I could say angles across from congruent sides are congruent. But isosceles triangle give me base angles congruent. So check, I've got that. Now, I need that other side. So they told me D was the midpoint, so I can say that AD must be congruent to BD. And that would be because midpoint implies 2 congruent segs. So, check, check, check. That allows me to say now that all 3 are checked off that my triangles are congruent. So, triangle ACD is congruent to triangle BCD. And the reason for that was SAS. If you had done it with reflexive property, it would be SSS. And now I need to say to myself, okay, is that all I needed? Now, look at your proof statement. That is all that it asked me to prove, so that means I am done. I've shown what I needed to show. Again, send questions as we're going. I'm seeing a few rolling in, and we're going to go from there. All right, you guys take a look at this next one. I'm going to look at the couple questions that I just saw roll in, and then we're going to talk about this. All right, these are live stream related questions, so I'm going to answer these pretty quickly. So, okay, so we want to show here that these two triangles are congruent. This is a really common scenario that you're going to be given where it looks like they're intersecting, and the first thing I think when I see this is vertical angles. So before I even go anywhere, sometimes I mark that. I know that those are going to be congruent because they're vertical. Now, I'm told that BA bisects CD. So CD is what is getting cut in half. BA is the thing doing the cutting. So CD is getting cut in half. That means that these two segments will be congruent. That does not mean they bisect each other. That does not mean that they're parallel. That doesn't mean any of that. What that means is that CD is getting cut in half. Okay? Now, the other thing I see is perpendicular. And perpendicular to me automatically makes me think about a right angle. So AC is perpendicular to CD. I know I would have a right angle there. And DB is perpendicular to CD. I know I will have a right angle there. So I see here, looking at my plan, I've got angle, side, angle. So that's what I'm going to go with here. My plan is ASA. So, statement and reason. So number one, again, is your given. Always, every time. Make sure that you're actually copying your given into there. Number two, I'm just going to go in order. So the first thing that I saw, angle-wise, was to do vertical angles. So I'm going to call this angle 1 and angle 2. Again, you could name it with 3 letters, but a little faster to say angle 1 and angle 2. And those are congruent because vertical angles are congruent angles. Again, don't just tell me vertical angles. That's like screaming toast at me. Make sure that you know vertical angles are congruent. So that's an angle. Now, a side, well, I'm told that this bisects it. So a bisector gives me a midpoint. So here's what I can say. E is the midpoint of CD because whenever I talk about a bisector, I want to know what type. So a segment bisector. A segment bisector implies a midpoint. And a midpoint is going to give me congruent segs. So then I could say CE is congruent to DE. And that is because a midpoint implies 2 congruent segs. Check off your segments. Because again, there's our first congruent statement, there's our second. We can only check them off when we do the congruence. All right, now we need the next angle, perp. Perp should make you think right angle. So I'm going to say angle C and angle D are right angles. And the reason is because perpendicular implies right angle. And then if they're both right angles, doesn't that mean they have to be congruent? So then I would say here, that means angle C is congruent to angle D because right angles are congruent. So that is my third and final congruent statement. So that is that. So now what I can say in my step 7 is my triangles are congruent because all 3 are checked off. ACE is congruent to triangle BDE. And my reason is angle, side, angle. Now I'm always going to ask myself, is there anything else that I need to show? And in this case, there is nothing else I need to show. That's what they wanted me to prove. So I am good. Now, I got a great question on the live stream. They said, could we use alternate interior angles here? Often we do, but remember, alternate interior angles come from knowing the lines are parallel, and that was not given to us. So unless you're given the fact that the lines are parallel, you don't want to throw in alternate interior angles. Now, could you show the lines were parallel? You could, but it would be a lot more steps. Okay, let's move to another one. This next one, just moving this up here, gives me that I've got BA congruent to DA and CA bisects angle BAD. This is almost identical to the one that we did before. So let's move down to 3, okay? So given BC and AE bisect each other at D, I want to show that ABD is congruent to ECD. Now, here's the crazy thing on this one. There's a lot of triangles, right? We've got a big one, another big one, a one in the middle, and then some little ones up top. So let's look at the triangles we actually care about here. We care about triangle ABD, and we care about triangle ECD. So those are the ones I actually care about. Those are the ones I'm going to look at. So, first of all, my good old friends, vertical angles. They're hanging out. So I already know that. Now my given says BC and AE bisect each other. That means they cut each other in half. So BC gets bisected and AE gets bisected. So once I mark that, I see here that I have SAS. That's my plan. So let's start this puppy out. So statement and reason, again. I know this is a lot to squeeze in. I'll do some zooming in and out. So number 1, again, given. No, the first thing, again, we saw were right angles. So I'm going to call that 1 and 2. So angle 1 is congruent to angle 2. And I just said right angles, and I meant vertical angles. So the reason there is vertical angles are congruent angles, right? And in my plan, that's the angle pair. So check that off. That's good. All right, now I need some segments. So segments, I know that I see which ones I'm going to get congruent. But bisect implies midpoint. So what I can say here is that D is the midpoint of BC and AE. And the reason that I know that is seg bisector implies midpoint. Now, a midpoint gives me 2 congruent segments. So then I can say that BD is congruent to CD and ED is congruent to AD. And my reason for that, again, same reason, would be midpoint implies 2 congruent segs. So let's look. We've got 1 congruent statement, 2 congruent statements, 3 congruent statements. Once I have all 3 of those, I've checked them all off. That allows me to say the triangles are congruent. So my step 5 here would be triangle ABD, and I know this is overlapping, is congruent to triangle ECD, and the reason would be side, angle, side. Let me shrink this down just a tad. Okay, same questions on those. Those are kind of the starter proofs. We're going to move into some harder ones now. So the next one I would say is, well, what if the proof statement isn't just to show the triangle is congruent? Here's what we always do. Boil it down to a triangle proof, right? Show the triangles are congruent, and then use corresponding parts. And this word is super duper duper important. If you leave that word out, you wind up not proving what you want to prove. Okay? The other thing, and some of your teachers or some of your tutors may have shown you this, if you use that abbreviation and you misplace some of the letters, you will get no credit. So I would not use that abbreviation unless you are 100% sure and you would bet $1 million that you are going to get it right. Because otherwise you abbreviate it wrong because you're nervous or you forget, you lose all credit for that. Okay. So let's do some of these. Here's what I would want to see from you. I would want to see triangles congruent implies corresponding whatever, either segments or angles, are congruent. So let's do some examples of this. So the first one, AC is congruent to AR, and angle 1 is congruent to angle 2. Okay, let's mark that. AC is congruent to AR, and angle 1 is congruent to angle 2. And I want to show angle 3 is congruent to angle 4. Common mistake. Number 1, do not mark this. Because you're going to assume it's a given then. Do not mark it. That's what we're going for, but don't mark it unless you do it in like a different color or in some other way. So you remember that's not your given. So let's come up with a plan. First, to just get the triangles congruent. So I see I have a side and an angle, and vertical angles are calling out to me. I see this, I think vertical angles. So I'm going to mark these congruent. Remember, I'm using a different number of arcs because it's a different angle pair. And then I see angle, angle, side in both triangles. So my game plan here is going to be A, A, S. Now let's look at our given. Side was given to me. Angle was given to me. So I need one more pair of angles. Okay, one more pair of angles. So I'm going to use the vertical angles that I used there. And you can title these however you want. I'm going to call them angle 5 and angle 6 because 3 and 4 is already taken. So statement, reason, number 1's your given. And notice that covers 2 of your congruent statements. So now I'm going to say, well, angle 5 must be congruent to angle 6 because vertical angles are congruent angles. That is my third congruent statement. I've got 1, 2, 3. So now remember, 3 statements does not mean I'm done. 3 statements means the triangles are congruent. So now I could say triangle ACL is congruent to triangle ARS by angle, angle, side. And now's where that last step comes in, and I just got a good question on the live stream that we'll answer in a second. Now I can say angle 3 is congruent to angle 4. And that's because triangles congruent implies corresponding, these are angles congruent. Now on the live stream, Caroline asked, could we use CPCTC in place for that reason? Yes, but if you write it wrong, if you forget the order, if you miss a letter, it's wrong. So if this makes sense to you, I would use this, okay? Do not chance it on the Regents. Write what you know. Don't try to be lazy. You have 3 hours. You have so much time, okay? Don't try to chance it unless you're sure, okay? All right. Let's look at this next one. So I'm given the angle NLM is congruent to angle LNO. Hey, those are alternate interior. I already see that this would mean I have parallel lines. I'm also given the angle OLN, that's this one, is congruent to angle MNL. That's this one. Hey, those are alternate interior too. There's a Z, right? So this is actually a parallelogram. You have opposite sides parallel. I want to prove that angle M is congruent to angle L. Now, you could get real fancy here. You could prove it's a parallelogram and then say because of that, opposite angles are parallel. But let's do this as a triangle proof. So I see here already that I have 2 congruent statements, angle and angle. What else do I see? Well, there's no vertical angles. There's no like segments that I see clearly, except I see that this segment overlaps between those 2 triangles. So that would be congruent to itself by reflexive property. And that gives me angle, side, angle. Now look in your given. You have 2 congruent statements already. One for an angle and one for another angle. So I am going to start statement, reason, number 1, given. And my given covers 2, count them 2, of those congruent statements. So I'm going to start on step 2, which needs to be a side, because that's the thing that's missing here, right? We said reflexive property would give us that, so Ln is congruent to itself by the reflexive property. And now I can check that off, because that is my 3rd congruent statement. And then I have all 3 checked. That allows me to say the triangles are congruent. So triangle LON is congruent to triangle NML by angle, side, angle. So my last step then would be to say angle O is congruent to angle M because I know that I have congruent triangles, and so that implies that the corresponding angles would be congruent. All right, let's get a little tougher here. So, that one's not a little tougher. Let's look at this one. Okay, this one was actually from last June's Regents, and it's one where I want you to look at the proof statement and know that you know so much, and even if you weren't sure how to get there, you could get 98% of the way there. So remember, things boil back down to a congruent statement, or a triangle proof, right? I want to show that I have parallel lines. So don't assume that, right? I want to show that. But when I hear parallel, I often think alternate interior. So if I could find a pair of alternate interior angles that were congruent, that would give me parallel lines. So that's what we're going to think through here. So let's look at what they gave us. So RS and TV bisect each other at X. So these would be congruent, and these would be congruent because X would be the midpoint. And it tells me that TR and SV are drawn. Great. Doesn't say they're congruent. Doesn't say anything else. Glaring at me is this. Vertical angles. So I'm going to label that. So I'm going to say that's angle 1 and angle 2. So already I have a plan, and that plan is side, angle, side. So let's get to proving and see what we can get. So side, angle, side. Statement, reason. Number 1, given. And I'm going to copy that directly down. Again, make sure that you're copying it. In my given, how many congruent statements do you see? I see 0. Big fat goose egg. There are none. So I need to get all 3 congruent statements here for myself. So I'm going to start with my favorite, which is vertical angles. Angle 1 is congruent to angle 2 because vertical angles imply congruent angles. Angle, check. Got it. There's 1 congruent statement. Now, I need the 2 sides, and I got that from the fact that there was a bisection. But remember, a segment bisector gives me a midpoint. So, step 3, I'm going to say X is the midpoint of RS and TV. And the reason I know that is segment bisector. Remember, don't just say bisector. Tell me what type. Implies midpoint. Once I have that, again, still not a congruent statement, now I can say that those pieces must be congruent. So TX is congruent to VX. And let me shrink this down a wee bit. And RX is congruent to VX. And that is because midpoint implies 2 congruent segs. Now, congruent statement, segment. So I now have all 3 checked off. So what I know now is that my triangles are congruent. So triangle TXR is congruent to triangle VXS. And I know that by side, angle, side. Not done. So now I know the triangles are congruent. That's 90% of the battle. I want to show these are parallel. So what I'm going to look for are alternate interior angles. And I see them. I see that like this and this would be alternate interior angles. You could also use T and V. So what I'm going to say is this. I know that angle R should be congruent to angle S. And my reasoning for that is that they are corresponding angles. So congruent triangles implies corresponding angles congruent. Well, now I see I have alternate interior angles congruent. So now I could say that TR is parallel to SV. And my reason would be because I see that my alternate interior angles are congruent, implies that my lines are parallel. That was a Regents proof, right? None of that is beyond what you guys are capable of. So don't let the fact that something looks a little tricky in the proof get you hung up. Just think about what you know. Parallel lines, normally think alternate interior angles. Okay, let's look at another one. How about this one? Okay, so X is the midpoint of SU. So midpoint, that automatically tells me that I get some congruencies. And VU and ST are parallel. Notice, not congruent. I'm marking them with arrows. Not congruent, they're parallel. Parallel lines make me think alternate interior angles. So I want to show that X is the midpoint of VT. I want to show that basically this is getting bisected. So I'm going to pick two triangles that those all seem to be parts of here. I'm going to pick this top triangle, and I'm going to pick that bottom triangle. Because now I can use the alternate interior angles, and now I can use the fact that I already know that that one pair of segments is congruent. So here's what I'm going to say. I already know that segment is congruent. Also, I could use like this and this, parallel lines. I could also use this and this. And I see vertical angles. So my good friend vertical angles are hanging out here. So you've got a lot of options of how to do this one. I'm going to go with vertical angles and alternate interior. I'm going to use all three. You don't have to. You could just use alternate interior twice. So I am going to use angle, side, angle. And this was a chart that we used to plan before. So again, if you want to use this, use it. It might help. So I know that I had the side coming from the midpoint, right? I know that I have vertical angles, and I know that I have alternate interior angles. And the congruent statement, I could write each of them out. I'm going to put mine in my proof, but again, this is how we always did our planning, so use this if it helps you. So I'm going to start with this. In my given, there are no congruent statements. There's a parallel statement, but there are no congruent statements. So I can't check anything off yet. So now I'm going to say step 2. Okay, step 2, I'm going to use this midpoint fact. So if that's the midpoint, then I'm going to say that SV is congruent to, SX is congruent to UX. And the reason there would be midpoint implies two congruent segs. Boom. There's one. Now I need my angles. So let's start with the vertical angles. I'm going to call this angle 1 and angle 2. Make sure you mark it on your diagram. Angle 1 is congruent to angle 2 because vertical angles imply congruent angles. Boom, check. Now, I'm going to use the alternate interior. That's 3 and that's 4. So I'm going to say here, angle 3 is congruent to angle 4 because parallel lines cut by a transversal implies alternate interior angles congruent. Boom, check. So now that's going to give me that the triangles are congruent. So triangle VXU is congruent to triangle TXS. And that was by angle, side, angle. So now I want to show it's a midpoint. And a midpoint, remember, comes from congruent segs. So which segments would need to be congruent? Well, this one would need to be congruent to that one. So now I'm going to say VX is congruent to TX. And I know that because congruent triangles implies corresponding segs congruent. And then, because that's true, I can say X is the midpoint of TV or VT. And my reason for that would be because the point divides the segment into two congruent segs. And so that means it's a midpoint. Now, could you say that in your own words? It's dividing it into two congruent segments? Sure. But you want to know that you have two congruent segments, and that implies midpoint. So again, the point I want to hit home to you guys is, just because this looks scary, don't let that intimidate you. Everything boils back down to a triangle proof, okay? So we are going to do more practice with these. We're going to do a night where we practice some with quad properties, but this is kind of a basic of getting back into them. We did about 45 minutes, so I'm going to hang out for a couple minutes, send me any questions, and we will go from there. Thank you guys for tuning in. You are awesome. I will hang out for questions, and have a good night.